Hello class, welcome to Module 3. In this module we get into some new fun stuff dealing with data manipulation. So a couple of things we're going to do here. We're going to do some file I/O, including some web scraping, and we're going to get an introduction into Numpy. First topic, web scraping and file I/O. There's kind of a lot in this topic. I might break it out into multiple topics in the future, but right now the two are in one module and they're kind of similar, so they fit together. So, as we all know, there's a great deal of valuable data being created every second on the web. If we can gather that data together and store it in a clean, structured way, it can be used in our programs. And I mean, the amount of data available is insane. So let's see if we can grab some of that and put it down into a structured format. So I'm going to do a web scraping example. This is adopted from one that I found on RealPython, but I'm going to step through all of the information here. First off, when we're doing this, for this example, we're going to need to include a couple of libraries. We need to include the requests module, the context live module, and then BS4's beautiful soup. Requests are good for making web calls, and Beautiful Soup is good for taking that data that we pull down and putting it into a more structured format for us to work with. So first thing I'm doing here is I am going to create a function called getAPage, and then it takes a URL as an input. It establishes our header, because when we make a call to a website, we need to give a header with that, so that's there. And then using the with functionality, I'm going to get the URL using my headers, and then as a response, I'm going to return that information. This won't do anything yet, obviously, because I'm just creating the function. I haven't utilized it yet. So here, you can see I'm creating a variable called raw HTML, and then I'm calling that function with a URL. So today we're going to grab some information off of Craigslist. I've chosen the recreational vehicles section because I'm into camping and I'm always keeping an eye out for a good deal on a different camper. So when I run this, you can see that it has completed, and so now I have raw HTML scraped from this particular page. That HTML isn't going to be very useful, so we need to start processing it into a more usable fashion. So I'm going to utilize Beautiful Soup, as I said. I'm going to take that raw HTML text that I just downloaded, and I'm going to use an HTML parser and store it into a variable called HTML. And then I'm going to look at that data that I just stored in my HTML, and using findAll, which we've used that before, that's under the re library. You can see I'm looking for li inside of a class called result row. And I want to show you this so you can kind of understand what that means. So I'm going to grab this URL. I'm going to go to this page. This is the page that we're trying to scrape right now. If I right click on this and go to view page source, this is what it actually looks like to a computer. So this is all the information that gets rendered on the page. I want to, in this case, in my code, you can see I'm looking for a class of result row, and then I'm searching for li. So I'm going to just grab this here, and I'm going to go over and do a find on it. And you can see that I have li in result row, and I can grab information out of that row. So when I run this, you can see that I get the type of the posting is a result set, and the length of the posting is 120. So that's telling me how many postings there are. And then if I print one of those postings, you can see, if I come out of this view, you can see I get a whole bunch of information back, essentially the HTML from that page in an easier to consume format, because Beautiful Soup made it easier to work with. But all of this information here is still not in a format where we can do a lot with it. We can start to see some information here, like with that you see the result row and the PID and the date of repost, and you can see the price here, which we'll be grabbing that later, the date timestamp, description of the listing, but those kind of things aren't super useful yet because I haven't pulled them into a structured format where I can observe them. So I'm going to then, I'm just going to keep it in this mode so we don't have to keep bouncing back and forth. I'm going to just pull the data for a single posting just to make sure it works. So that's what this code here is doing. You can see I've got a variable called post1price, and I'm pulling the text from posting 0, which is the first posting on the page. And then I'm actually going to strip that. So you can see I'm stripping all of the junk off of it, the extra stuff that's not necessary, and then reassigning it back to that variable. And then I'm going to print it. And I'm just going to comment this section out here quick so you can see what that looks like. So you can see I was able to pull the A text off of the first listing and then strip the junk off of it so I can get the $800. So if I go and look at A text, again in that HTML, no, it's not what I want. Here we go. So I'm going into the A. This is the first, I believe this is the first listing, or maybe this is not the first listing, but regardless, I'm going into the A section and pulling the price off of that because this is the actual text in that box. All of this, the rest of this is information around it, and then this is the actual data. So this is what I grabbed when I looked at this particular portion, the A text for that posting. So I strip all that out and I can print it. Now if I go here, I can also do these things. Grabbing the time, by looking at the time section under the result date class, and then I'm grabbing date time and assigning that to a variable called post date time. You can see that I print that out there. So we're starting to pull pieces of information out of that HTML text. As I continue down, I'm going to grab the title for the first one. So again, I'm finding within the class result title HDR link. So if I copy this, do a find, you can see the class is result title HDR link. Once it's found that, I can grab the text from it here. So you can see that in this case, it's 2003 pop-up 10. And then I'm assigning that information to a variable called post1link, or post1title. So you can see here's the link and here's the title text. So I was able to pull the actual link to the page for that posting, because right now we're scraping the page that shows a whole bunch of listings, but I can grab the actual link to the specific post as well as description for that post. We'll need that later. Then continuing down, I can do the same thing for the location. There's a class called result hood that will tell you the location of the listing. So you can see that one is located in Des Moines. So that's just looking at the data for one listing. Now we want to go and grab the data for all the listings. So I'm going to need a few things here that I didn't have before. From time, I need to import sleep. This is to adjust the speed of the page reads. I already had the regex library imported, but if I didn't, I'd have to have that. This one is important, this from random import rand int. We utilize this here to randomize the amount of time between page requests. And we have to do this because sites don't actually like being scraped because it uses up bandwidth on their side and can actually slow down their sites if someone's hitting them too much. So they put in steps to prevent people from scraping. Well, by putting a random page load time in there, that's one way that you can decrease the chances of you getting blocked, because you're not going to just request the page every 500 milliseconds. You're going to, once it might be 500 milliseconds, the next time might be 800 milliseconds. So it doesn't look like computer created traffic. And then I can get some warnings if something goes wrong, and then clear output option, and then I'll need Numpy here. We're going to learn about Numpy later in this module, but we'll utilize it here a little bit. So I've got all that stuff imported. And now I'm going to figure out the number of results, because this is important, because later on we're going to try to scrape all of the listings that are currently available in this category. And so we need to know how many there are so we can scrape them all. So results num is the variable, and it's going to find in the class search legend. You can see here, it's going to find the total count. So you can see here it's 187. So it's grabbing that information out. And then, yeah, I'm just going to print it here so you can see there's 187 listings involved. And then I'm going to figure out the number of pages based on that information, because if I go to the actual site, you can see, well, there's 187 results. They don't put them all in one page. You get to the very bottom of page 1, and you can see it's 1 to 120 of 187. So I want to scrape all of the listings, not just the first page. So I will need to be able to figure out how many are on this page, and then be able to go to the next page and grab the rest. So that's how this works. It tells me how many pages there are total, so I know how many times to load a new page. And then if I print this, you can see there is 120 on page 1. That's not super useful here, but it's telling you how many are on a page, and then you can figure out how many total pages there are. This next cell, all I'm doing is just creating some empty variables to work with. I'm starting with my iterations, since I haven't iterated through anything yet. It starts at 0, and then I'm just initializing a bunch of empty lists. This is where I'm going to put all the information from the listings as I scrape it. Now this cell is the big one. This is where we're going to do our scraping. So it starts with a for loop that says for page in pages. So this will happen, this for loop will happen for each page. So we have 2 pages, so really we're only going to loop twice. It's going to do all these things. So first, it's going to grab the response from the page, from the initial page, and then we've got that random interval where it's going to sleep to try to change the speed that we're doing these calls. And right here, it's going to give us a warning if we don't get a 200 response. 200 means that a successful connection. If I get like a 500, that means access has been denied by the site, or they're 404. Obviously, everybody knows 404 means the page won't load, things like that. So it would bring that back to me if there was an error while trying to access the page. And then I'm going to grab the page HTML and parse it out with beautiful soup like we did earlier. And then I'm going to find all the posts here, and then I'm going to start extracting data from those posts. So for each one of those posts, so for post in posts, it's going to find, as long as the neighborhood is not none, it's going to grab the date time and then append it to a variable called timing. It's going to find the neighborhood and then append that to the variable called post hoods. It's going to grab the title and then store that in title texts. And it's going to grab that link and put that link into a variable called post links. And then if there's any white space here, it's going to take that text and, I'm sorry, what this does here is if the price is not there, which sometimes you see posts that don't have a price in them, I want it to be 0, so my value stays as an integer. So if there's no text, it's going to change it to a price of 0. Otherwise, it's going to grab that post price from the site. It's going to strip off any $signs, and it's going to strip off any commas, because I can't make it an integer if it has those there. So it's going to strip all that off, and then it's going to assign it to a variable called post price, which then is going to get appended to the end of the list called post prices. And then once it does all that stuff, it's going to increment iterations. And then just so I know what's going on, it's just going to bring back to the screen saying, hey, it's finished scraping one of the pages. And then it will start over again, scrape until we've done all of our loops. So 4 page in pages. In this case, we're only doing 2. So it'll go through twice, and then we'll get scrape complete. So if I run this, it's actually going out and making the calls. You can see that the cell is still executing because it's making those calls and grabbing the data over and over again. And then if you come down here, you can see it scraped both pages successfully and then just said scrape complete. That's just feedback to the user so they know that it's done. Okay, so now I've got a whole bunch of lists created with a bunch of data into them. I can now take all that data from my lists and load it into a dictionary of lists, or whatever makes sense for whatever data you're trying to work with. But this is what I'm doing. I'm creating a dictionary of lists. So first I'm going to initialize an empty dictionary, and then I'm going to do a for loop for listing in range from 0 to the number of posts. It's going to create an item in the dictionary. So it's going to be that item in the dictionary. It's going to get the post timing, the post hoods, the post title, post price, and post links. And then I'm just going to go ahead and print the whole dictionary, which of course is going to be a ton here, right? A little hard to read, but you can see that it's the beginning of a dictionary. and then there's just data. But let's just grab, I'm gonna, instead of do this, that's why I've got these other ones commented out, we can limit it to just a single dictionary item. And you can see that this dictionary item is a list that includes all of the information for one of the posts. So you can see that I've got a date, I've got a location, I've got a listing, a title, I've got a price, and I've got a link to the page. Now I've got my data in a much more usable format where I can actually do something with it. I just wanted to show here that I can specifically grab a specific piece of data. So like if I wanted to do an analysis on the prices, maybe for the listings, I don't know what I would do, but I could surely come up with something. I can specifically grab them like this, where I say for an item in my dictionary, the dictionary being the whole thing, print the item's third or fourth piece of data in the list. So this is the item that tells you which dictionary item, and then this is where in the listing. So 1, 2, 3, 4. It's grabbing the fourth piece of data in that list, in that dictionary. And then I'm iterating through the whole thing so I can get a list of, or I can get an output of all of the prices for all of the listings on that site for campers. I can do the same thing with any of these if I wanted to do analysis on it. But I mean, obviously, I'm just printing it to the screen here. I could have loaded it into another list. I could have output it. I could have analyzed it in some manner. I've got the data in a way now where I can start really working with it and digging in. So it went from a very unstructured format on a website down to something that I can actually do something with. That's really the power of scraping. Now, that's the end of that scraping part. But I just want to point out a site like Craigslist lends itself very well to scraping. Because of the way it is structured. You're going to find that each site has its own structure, and in some cases they do not lend themselves to scraping well at all. I attempted to do a scrape for this demonstration with Wikipedia, grabbing some tables off of Wikipedia, and I had a lot of trouble with it, and it got to the point where it's too complicated to try to explain. So just because it's easy here, don't assume that it's going to be something that's easy on every site you come to. I just want you to be aware of that. There is typically a way to do it, but it may involve more complexity than what you are seeing here. So just be aware. Continuing on, I'm going to go back into the other view here since some of these will be a little bit shorter now. So that was web scraping. I wanted to also show some file input into the system. We did some simple file I/O in Python 1. I want to continue expanding on that knowledge that we've gained because, again, you want to bring data into your system to be able to work with it. A lot of times you're going to work with files or CSVs or things of that nature, and you need to be able to pull it into your program and be able to work with it. So I'm just going to throw this example out here. One of the nice things to mess with books is Project Gutenberg has open source books, or public domain books is what it actually is, in a digital format that you can download for free and you can utilize as you please. So I like pulling down old books and doing simple analysis on them just because it's fun and you don't have to spend anything. You have to worry about, how you're using the data because it's public domain. Moby Dick is one of those books. So I went out to Project Gutenberg, pulled down the book, and then I copied chapter 1 into a text file. So if I go over to my view here, you can see, okay, well, it's not going to let me look at it in that manner. So I'd have to look at it through my browser or through some other manner. But it's just the text of Moby Dick. I don't know why it's acting like that, but you can see it's chapter 1 of Moby Dick. So I'm going to work with that. So the first thing I'm going to do is using my file input functionality in Python. This is my preferred structure for utilizing this. The nice thing about doing it this way, if you recall, is that when you use with open, once you've completed what you're doing with it, it automatically closes that file connection. It keeps things a little bit cleaner so you don't leave connections hanging open. So I'm going to say with open Moby Dick chapter 1.txt. Because it's in the same directory, I don't have to tell it where it is. It's actually sitting in the same directory as this code, so that's easy. And then I'm just doing a read, so I'm not editing it in any manner. I'm just utilizing it. I'm casting it or aliasing it as an input file. And then I'm just going to say for line and input file, print the line. So I'm just bringing it to the screen right now, just so you can see, well, here, I didn't have to open the file directly. I could do it right here. So each line you can see it's been imported into my program. I'm not really assigning it to anything right now. I'm just bringing it to the screen. So that's all well and good, but let's do some more with it now. So continuing on, I'm going to import that regex library again. Even though I already imported it, I'd just like to show you again. And then I'm going to figure out the word count of all the different words in Moby Dick Chapter 1. That's what I'm attempting to do in this demonstration here. So again, I'm going to open that file, and I'm going to read it and do as input file for the aliasing. Now, for each line in the input file, I'm going to do the following. First, I'm going to turn everything into lowercase, because for my analysis, I don't really care if it's uppercase or lowercase, and I want to be able to count them, the word itself, not necessarily whether the word is capitalized or not. Now, you may want to do something different, right? You may actually care if it's capital the or lowercase the. That's fine. In this case, I'm lowercasing everything right off, just so I can make my counts a little easier. And then I'm going to get rid of all my punctuation, because I'm just now analyzing the words in this. So I'm going to create a variable called line clean, and then I'm going to do a re.sub, which we did a little bit of that last week with regexing. And this is the syntax I'm using, where I'm saying, hey, if it's not a letter or a space, turn it into nothing. Or a letter or a space, turn it into nothing. So I'm taking all of that data and just cleaning up all the punctuation out of there. Okay, and now that I've done that, I'm going to split it into individual words, which we saw split again a little bit last week. So just line clean.split, assigning it to line split. And now that I've got basically a, well, if I just, I'm going to end up getting the whole thing. I was thinking I could just run that line, but it's all going to run together. But I'll show you that here in a little bit. But you can see I split it out into individual words and assigned it to a variable. So now I've got a variable that is a list of every word in that line. Now we can add it into our dictionary. So I want to do counts, right? So for each word in my line split, we know line split is a list of the words in one line. For each word in it, it's going to check to see if the word already exists in my dictionary as a key. If it does exist, I'm going to increase the value of that count by 1. If it doesn't exist, it's going to add the word to the dictionary and assign it a value of 1. So the first time it sees a word, it's going to add that to the dictionary as a new item. If it's already seen the word, it's going to increment the value of that dictionary item for that word. Okay? So if I run this, you can see I get a giant dictionary, and each key and value is a word from the book and the number of times it sees it. And you can see that a lot of these are going to be 1, but like, for instance, the word some appeared 11 times in that little chapter. The word by appears 8 times. The word flourish appears once, things like that. So I've got a word count for every word in that chapter. It's still not really great to look at, but I've got my data in a structured format now. So let's do something with it. Right here, I'm going to first sort it by the items. And I'm using lambda here because lambda fit well for this. Basically, the key is going to be the X for the second item in the dictionary. It's not super clear the way I'm saying that, but if I run this again, you can see I now get a much more organized list, starting with the highest count word and working its way down to anything that doesn't appear very often. So I've got, again, a more organized thing that I can look at and see what's common. Now, of course, anytime you're looking at text analysis, these kind of junk words or filler words don't really tell you much. But as you work your way down, you get into things like, let's see, voyage would be an interesting word. Sailor, whaling. I mean, you get enough of these kind of words, you kind of get an idea of what this passage is really about. Passenger, and on and on and on. So something that's a little more structured to work with. And then here I am exporting that data out into a file. So if I run this, it will create a file called Moby Dick. That's not right. It'll create a file called Moby Dick word counts.txt. And then if I go over here, it was already here because I've run this before, but you can see I've got a file in the same directory Moby Dick word counts. So I can take that data out and take it somewhere else if I wanted to work with whatever program I'm interested in working with. Maybe I want to visualize it or something like that in another program. So that's just a good file I/O example. You'll be doing something similar to that in one of the assignments this week. Continuing on, topic 2, I don't really have anything to talk about here. I've just got some links in Blackboard that give you some introductory information to the SciPy library. SciPy library is a very popular library. It has several different modules in it that are used by people, including Numpy, which we're going over this week, and Pandas, which we'll be going over next week. There's also some other libraries there that are really useful. So it's worth actually familiarizing yourself with the library. It's commonly used in data analysis, data science, pretty powerful stuff. So worth having a look. But for now, we're just going to jump right into Numpy arrays, or NumPy arrays. I have a tendency to do that. It's NumPy. It stands for numerical Python, is what the shortened version of it is first. But what I'm going to show you first is just a bit of a review on regular arrays. We did regular arrays in Python 1, or just normal arrays, normal one-dimensional type arrays. So here's just an example. This is a reminder. If you want to do arrays in Python, you have to import them first. And then this is the structure you would do when you're creating an array. So you can say my array equals array.array. You have to assign a data type to it. In this case, I'm assigning an integer data type. And then this list is what goes into the array. And then if I print this, I essentially get it echoed back at me. So this array has been created of type integer with these items. Remember that arrays have an assigned data type. You cannot add different data types to that array once it's created. They have to be a single data type. I can't put a string in here at the end if I want to. That's not allowed because this has been assigned as an integer array. I couldn't put a float in here because it's an integer array. And you can, here's just a few things you can do with it. Here, you can grab the first item in the array by the index position. Here's a couple other things you can do. I can print a portion of the array. I can say, hey, give me array position 0 and 1 and 2, the first 3 positions. 0 and 1, because 2 is not inclusive because it's at the end of the range. I could just reassign a value in the array. So here I'm saying reassign the second position in the array with the number 5. I can append to my array as long as I'm using the right data type. So I can add a 9 to the end, or I can remove that 9 at the end if I want to. So you can see here, I'm outputting the first 2 items in the array, as I said. I'm adding 9 to the array and then removing it. Okay. And then you can also pop things off an array, just like you can do with lists, where when you pop off the array, it just takes the last item in the array, removes it from the array, and then makes it available to use. So if I wanted to assign it to a variable or do something with it, that's what popping off the end of an array does. Okay, so that's just regular arrays, just as a reminder. NumPy arrays are multi-dimensional arrays. Now, we really demonstrate them here in this module in just 2 dimensions, but NumPy arrays can also be 3-dimensional. They're a little harder to look at on the screen, so I'm not doing it here, but you can do 3-dimensional arrays. So here, I'm importing NumPy as NP. Pretty well everybody does the alias of NP, so I would just suggest you do the same. Makes it easy to read as you're trying to read through the code. And when you go online to look at this stuff, that's what you're going to see other people doing. So I've got my array variable, and then this is how I'm creating my array, np.array, and then I have to create a list of lists for each one of the item, or each one of the rows in the array, essentially. So this is the first row in the array, the second row, third row, and fourth row. And you can see when I print that, I get a 4x4 2-dimensional array. So what can we do with that now? That's very interesting. Arrays are obviously used a lot in statistics, so we have to be able to do this kind of stuff. But here's just some simple things we can do in Python with it to manipulate those arrays, or just look at portions of them. So here you can see I'm just working with that array I created just before. My array.shape. It'll tell me the height of the array and width of the array. If it was 3 dimensions, it would tell me the depth, then the height, then the width. I can output the number of items in the array. So you can see print my an array.size, size is 16, and then what's the data type on it? You can see it's an int32. Okay, so you can look at those kind of things just looking at information about the array. I can access specific data within the array. So here you can see I can print the maximum value in the array. This just looks through the entire array and brings back the highest value in the array. I can sum up the entire array doing .sum. So it would just add up all of the items in an array and give you the total. I just want to point this out before the next section. The axis order matters. If you have a two-dimensional array, the vertical axis is considered axis 0. The horizontal axis is considered axis 1. If it was a three-dimensional one, which I don't have a visual here, as I said before, axis 0 would be the depth of the array, axis 1 would be the vertical, and axis 2 would be the horizontal. That's important right here because I want to do a couple of things that involve the axes. So printing my array here so you can see it, and then I'm putting a blank line here so it doesn't all mash together. And I'm going to grab the maximum value along axis 0, and then I'm going to sum up. I'm actually surprised that didn't show up on the screen. No, hold on. My array is, I didn't actually run the code to create the array. I skipped it. There we go. There. Oh, I'm sorry. I see what I did here. I should have put another blank line here. This is where it gets confusing. So I'll do this. Now when I run it, you can see that it's going to give me the maximum value utilizing axis 0. Remember, axis 0 is the vertical axis. So it looks at this array, and it says in this column, 13 is the maximum value. In this column, 14 is. In this column, 15. In this column, 16. So it's giving us the axis of each or the maximum of each column in that array. And I can do a sum across axis 1. So if I take 1 plus 2 plus 3 plus 4, I get 10. 5 plus 6 plus 7 plus 8 is 26, and on and on. So it's doing a summation across the rows of the array. I can also do some comparison operators, I guess, here, or some true Boolean type logic here. So I'm printing the array again. Blank line again. So I'm printing the array, and then I'm going to create a variable called myArray_by3 to determine which one of these values in the array divides evenly by 3. And to do that, if we do modulus, we did modulus in Python 1, I'm saying for each item in myArray3, or myArray, do a modulus of 3. And as long as it returns 0, which means it divides evenly, it's true, but otherwise it's false. Okay? So you can already see, because it's already run, you can see down here, it returns false for everything that doesn't divide evenly by 3 and true for everything that does. You'll do something really similar to that in the assignment. So that's how you would do that. You can also grab slices of the array, or just portions of it, using indexing. So you can see, in this case, let me just print. Go. Now you can see the original array, and I'm grabbing a slice of that array. I'm saying give me from up and down, give me everything from index position 1 to 3, and going across, give me everything from index position 1 to 3. So what that's going to do is it's going to go down 1 and grab 1 to 3 right here. So you end up with actually the center of this particular array, 6, 7, 10, 11, get output there as a smaller section of the array. And then I'm assigning it to a variable just for printing's sake. So that's how you can slice an array. You can also do, what am I doing here? I think I just created a couple of, not exactly sure what I was doing there. Oh, okay, so I needed it for the next slide. So I'm creating 2 smaller arrays here, just 2 by 2 arrays. And then I'm going to utilize them here to sum those arrays. So if I want to do a summation of 2 arrays, I do numpy.add, or numpy.add, the first array and the second array, and then it will add them up element-wise. So I end up with 4, 6, 8, and 10, because it was 1 plus 3, 2 plus 4, 3 plus 5, 4 plus 6. So that's how I end up with that 4, 6, 8, 10. So that's addition across arrays. I can also do the same thing for multiplication. It just multiplies them element-wise, and I've just created a separate array to put the result in. I would suggest normally, unless it's absolutely necessary to create new variables for arrays, to put them in after you've made changes to them so you don't accidentally screw up your original array. Okay, so here's just a little bit more manipulation of NumPy arrays. Those are some simple things. We just continue it in topic 4. There's a ton of different ways that they can be manipulated. I won't be able to ever show them all to you. You may have to do research online if you're trying to do something that falls outside of what I'm showing you here, but just assume there are a ton of ways to do it. And if you have a need for manipulating it in a certain way, there is surely a way to do it. I'm going to start this one by creating a 2 by 6 array. Remember, 2 is axis 0, so that means it'll be height of 2 and then a width of 6. So again, I'm going to import NumPy, and I'm going to create a variable called another array. And it's going to be an array 1, 2, 3, 4, 5, 6, and 7, 8, 9, 10, 11, 12. And you can see that it prints out here, and it is 2 high by 6 wide. And now we can mess with that array a little bit. A common thing to do is to perhaps resize it. So as long as I am creating a resize of the array that has the same number of elements, I can do this. So by resizing, I'm saying, hey, instead of being 2 by 6, I want it to be 6 by 2. So I want it to be 6 tall and 2 wide. It will attempt to do it how you want it to as far as positions are concerned. But in this case, it goes from, it goes from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's how I decided to reassign the positions of the variables, or of the values. I can also do transposition. That's a normal mathematical thing that you would do with arrays. So I'm creating a new, or I think I actually overassigned my initial array. So I'm saying another array equals another array dot transpose, and then I print it. And you can see that the original array was one, or the one that was, so it was vertical before, and I'm doing a transpose, which flips it as well as changes it from a 6 by 2 to a 2 by 6. So you can see now it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 after the transposition. And then I can just go ahead and flatten it if I want to. So that's just by using a flatten method. And it just takes the second row and just puts it on the end of the first row. So now I've got an array that is 1 by 12. And then I can sort it if I want to. Make sure I got that. If I wanted to sort my array, I can do it like this. So my array.sort, that method, and then I print it. The .sort method automatically overrides the existing array. You can see I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then after all that, I can resize it to be 2 high and 6 wide, and then print it out. And after all that, I have the exact same array I started with, just for fun. So I did a whole bunch of manipulations with it, and I managed to get it back to being essentially what I started with. Obviously, you wouldn't normally do that. That's kind of dumb, but it was just for fun. Okay, that's all I have to show you as far as code is concerned. I'm going to just go into the module quick just to make sure that you know what the assignments are, and then that'll be it for this week. Okay, so this is module 3. And in module 3, we've got 4 topics, as I went over in the demonstration. And we've got 3 assignments. There's one in topic 1, one in topic 3, one in topic 4. So I'm going to go into the one for topic 1. And what I'm asking you to do, essentially, for this assignment is I'm not having you do a scraping assignment, although I do strongly suggest you try it because it's a very interesting challenge. Maybe do a different category that you're more interested than campers and just see if you can get it to work. But for the assignment here, I'm asking you to use the file that I used in the example. I want you to determine how many times the word old appears in the passage, how many times water appears, and the average sentence length in the passage. That's different than what I showed you, but I think with the skills you have, you should be able to figure that out. And then I want you to do the exact same thing with Sense and Sensibility, Chapter 1. You can find the link here. And then answer these questions. What does this scraped information tell you about these two passages? And what other interesting things can be done to find out information on these two passages? What can you do with the data that you have here that isn't just immediately straightforward? I like doing two different texts here because one of the really nice things about this is once you build something like this well, it doesn't really matter what text you're analyzing. You can just keep loading data in and the program can just process it. So once you get it built once, it's very reusable. And I ask that you submit your working program file. When you're doing your code, please make sure that you keep the text file in the same directory as your program, because then I don't have to rework your lookup for your file when I try to grade it. So I appreciate it if you would do that. So submit your working file. You don't need to submit the text file. I already have that. But also make sure that you put comments for the questions in your submission text. Okay? That's that one. And then the one in topic 3, I'm just asking you to do a little bit of Numpy array math. So just using these two arrays here, step through and do what I ask you to do here, and then just submit your working program file. So there's nothing here really that I haven't shown you, or it's very similar to what I showed you in all of the demonstrations, so you shouldn't have any trouble there. Just step through it. If you have any questions with that one, let me know. And then topic 4, I'm going to ask you to do, again, a similar thing, but maybe a little more complex, where you're manipulating the shape of the array, the size of the array, the order of the items in the array. So just step through each one of these directions and then submit your working program file for grading. Okay, that's it for this week. As always, this demonstration video will be uploaded. You wouldn't know that if you weren't listening to me already. And the program file that I created will be made available under the help area of the topic, module 3 help. So you'd see I've already got the link there.